Well, now we'll take a look at another example of a problem called coin problems or money problems. So here's an example. Diane has 95 cents in dimes and nickels. She has a total of 11 coins. How many are there of each kind? So my first step is to define my variables. X equals the number of nickels and Y equals the number of dimes. My next step after that is to write my equations. So I know that x plus y equals 11 because I had 11 coins total. I know that 5 cents, nickel, is 5 cents. So I represent that by 0.05. So 0.05 is how much that is in pennies, times x plus 10 cents, which is 0.10 times y, is equal to my grand total of 95 cents. And so that is how I show my second equation. Now in the last equation we had decimals also, and I didn't change my decimals, I left them as decimals. In this example I'm going to show you a little trick that you can do to get rid of your decimals if you prefer not to work with decimals. So I'm going to now solve my system. And so the first step that I'm going to do is I want to get rid of those decimals. So I'm going to keep my equation 1 just the way it was. I'm not going to worry about that yet. But here in my second equation with my decimals, I'd like to get rid of them. And when I want to get rid of them, what I notice is, hey, if I move that 2 decimal spots over, I'm not going to have a decimal anymore. Here, if I move that 2 spots over, I'm not going to have a decimal anymore. And then if I move that 2 spots over, I'm not going to have a decimal anymore. So what I need to do is multiply the whole equation by 100. And if I multiplied all of equation 2 by 100, that would move those decimal spots 2 spots. So if I had 3 spots behind the decimal here, I would multiply by 1,000. So you multiply by a power of 10, and how many decimals there are, it's how many zeros go here. So when I multiplied equation 2 by 100, I ended up with 5x plus 10y equals 95. Well, I still need to solve the system of equations. I got rid of my decimals, makes my life a little easier, so let's take a look at the next step. I decided I would like to get rid of my x's. Doesn't matter, you could choose to get rid of your x's or your y's, but I chose to get rid of my x's, so I am going to need a negative 5x here so that when I add these two equations, those x's will be eliminated. So I'm going to multiply my equation 1 by negative 5. So negative 5 times x gives me negative 5x. Negative 5 times y gives me a negative 5y. And a negative 5 times 11 gives me a negative 55. Don't forget to multiply both sides of the equation. That's a common mistake that students make. So now I can add my equations. When I add my negative 5x and my 5x, those get eliminated. When I add my negative 5y plus 10y, I get 5y. And negative 55 plus 95 gives me 40. Divide both sides by 5, and I get y equals 8. I'm only halfway there. I need to go back and find x. I decided to use my original equation 1, which said x plus y equals 11, so I substitute y as 8. And I solved for x, and I got x equals 3. This tells me that there are 3 nickels and 8 dimes, so I write a nice sentence. And then I need to show my work. 8 plus 3 equals 11. That checks out. And 10 cents times 8 plus 5 cents times 3, because I said I had 3 nickels and 8 dimes, that turns out to give me 95 cents. Finally, we'll take a look at a problem called a mixture problem. And a mixture problem would look something like this. How many liters of 10% rubbing alcohol solution and 5% alcohol solution must be mixed together to obtain 40 liters of 8% rubbing alcohol solution? So sometimes it helps to take a look at what a picture might look like of that. So here what's going on is I'm going to say, hey, I have a 10% solution and a 5% solution. I don't know how much I have of each of these solutions. I'm going to call one X and one Y. But I know I want to combine and mix them together to get 8% of a 40 liters. I want 40 liters total. I don't know how much of each I'm going to pour in, but when I pour them in, I want an 8% solution. So my first step is label my variables. X equals the amount of the 10% solution, and Y equals the amount of the 5% solution. Next, I make a system of equations. So my equation 1 is x plus y equals 40. My equation 2 is 10 0.10x plus 0.05y equals 0.0840, because when I'm talking percents give you decimal. And now again, I'm going to use that little trick that I showed you of multiplying by 100 to get rid of my decimals. So 100 times this side will give me 10x. 100 times 0.05y gives me 5y. 100 times 0.08 times 40 is going to give me 8 times 40. Because this is all multiplication, I only need to multiply it one time. So now what I notice is that I'm going to get rid of one of my variables. I decide to get rid of my y. That means I need a negative 5 here. So I do negative 5 times equation 1. So I get negative 5 times x gives me negative 5x. Negative 5 times y gives me a negative 5y. Negative 5 times 40 gives me a negative 200. I am now ready to add my equations. When I add, I end up with 5x. My y's eliminate, that was my goal, and I end up with 120. I divide both sides by 5, and I get x equals 24. Now I need to go back and find my y. So I'm going to use my first equation 1, which is x plus y equals 40. So I have 24 plus y equals 40 because I substituted 24 for x. Solve, and I get y equals 16. That tells me there is 24 liters of 10% solution and 16 liters of a 5% solution. I write my nice sentence. I go and I check my work. 24 plus 16 does equal 40. That checks out. 0.10 times 24 plus 0.05 times 16 does equal 40 times 0.08. And that checks out.